Here we are, last Matrices Notes. Last Matrices Notes. We're going to review the method that we learned for finding the determinant of a 3 by 3 matrix. So we take the first A1, 3, and we visualize crossing out the row in the column that 3 is in. And then here is the 2 by 2 that's left. Then we subtract A2, just changing colors here, A2. If I picture crossing out the row in the column that is now, that's subtracting -2, of course, 4, -1, -1, 1. And then adding A3, so plus A3 there is 4. And if I take out the row in the column, I get 4, -1, -3, 4. Then I find the determinant of each, right? So here, let's see, it's going to be 3 times -3 minus -4, which is -3 plus 4, right? Which is 1, so that's just 3. And then here this is going to change to a plus 2 times 4 minus 1, or 2 times 3, or 6. And then plus 4 times 16 minus, that's 3. So 4 times 13 is what? 52. So 52 and 9 is what? 61. Determinant of a 3 by 3. Now, there is another way to find the determinant of a 3 by 3. And it looks complicated, but really this one ends up being one that people like a little better. You're going to use these diagonals. Well, let me show you. First, you're going to recopy the first 2 columns right next to the matrix. So 3, -2, 4, and 4, -3, -1. And again, I'm just getting those from these first 2 columns, rewriting them. Now I'm going to do these diagonals. So I'm going to take the first diagonal here is these. All right, so now we're going to start our diagonals. So here, if I multiply those 3 together, I get -9 plus 4 times 4 times 4, 64, plus, that's going to be -2. So if I add those up together, that's 53. Then I subtract, multiplying up this way. So that's going to be +12, here -12, and then here is -8. So 53 minus -8 is 61. 61. Now, the reason that we're doing determinants of 3 by 3 matrices is to introduce what's called Kramer's rule. And before we freak out about it, we do not have to memorize Kramer's rule. Kramer's rule uses 3 by 3 matrices to solve a 3 by 3 system. And we remember 3 by 3 systems, and they were kind of intense, right? And Kramer's rule is kind of intense, but once we do it once, I think you'll kind of get the hang of it. So first we're going to figure out what this means in these 3 denominators. Determinant of A, where A is the determinant matrix. The determinant matrix is going to take those numbers, the A, the D, the G. So A is, the matrix A is going to equal here 3, -2, 4. I'm just getting those numbers from right there. Then 4, 3, or sorry, it's -3, -1. Then -1, 4, and 1. Does that matrix look familiar? Same one we just did. So if I want to find the determinant of that, again, I'm going to recopy those 2 columns. I'm going to do this whole thing and then subtract this whole thing. But I just did that up there, so I'm just going to steal here that the determinant of A is 61, because I just did that. So what that says to us is that the x-coordinate has a denominator of 61. The y-coordinate has a denominator of 61. The z-coordinate has a denominator of 61. So I just have to find the numerators. Now, if you look at the matrices for the numerators, so where are they getting the numbers? Well, you see this JKL here that replaces the X column, then replaces the Y column, then replaces the Z column. And you don't even have to worry about that because you don't have to memorize the formula anyway, but like if I wanted to find the numerator of X, I would take this column here and replace it with this column, 9, -14, -18. then I'm still going to have the 4, -3, -1, and the -1, 4, and 1. And I can still find that determinant the same way by copying down those columns and then doing my diagonals. So here I have -27. Now here this is going to be like some intense numbers, right? 4 times 4 times 18, let me see, 16 times 18 is 288, and that's going to be minus, and then here is going to be minus 14, right? Yeah. So let's see, if I add those together, -27, -288, -14, I'm getting -329. And like I said, I know it's annoying. So now we're going to multiply up, up, up. Let's see what I've got here. -18, I'm kind of crossing out my numbers. I think this is going to be -54, -36, and then 14 times 4, -56. Let's hope this works out. So this is going to be minus -146. So this turns out to be -183. Yes, we got it right. Oh, thank goodness. So that number is going to become my numerator. And now we're just like, please go into 61, please go into 61, and it does, so the x is -3. I'm kind of out of room here, so I'm just going to show you the answers. We would follow the formula and do the y and the z numerators the same way. The y numerator turns out to be 244, so y is 4. And the z numerator turns out to be -122, so z is -2. So the ordered triple is -3, 4, -2. It is a little tedious, I'm not going to lie, but I think it's actually easier than the old way we solved 3x3 systems by double elimination. And you don't have to memorize the formula, and there's only one of them on the quiz, and everyone usually gets it right. So that's Kramer's rule, and that is it, matrices, number 3.